Okay, everybody, the first day of our two-day explain part of the unit where we're going to go through some notes related to the Big Bang. So you should have your notes in Notability, Big Bang explain, send those over to Notability, and everything that we have underlined for you should wind up in your notes. And on your notes, there's a right-hand section as well that will go through some processing activities for you to help kind of handle this information as we're spitting it at you here. So some stuff that we did in class is we talked about what the Big Bang Theory is based on what we've talked about so far. So we've talked about CMB, we've talked about using the rubber band to stretch the imagination. We've talked about redshift as well. So trying to understand what the Big Bang Theory is. And then the second bullet point is a callback to that ways of knowing activity that we did. What is a theory? So remember, a theory is the current accepted explanation for something. The difference between theory and a law is like law is used and is found 100% accurately everywhere throughout the universe. And a theory is something that the science community has said, okay, yes, this is what we believe is the correct explanation for whatever phenomena. So like theory of evolution, or the Big Bang Theory here. So here's how life got to where it is today. Well, science thinks it's the theory of evolution. Or for us talking about astronomy, how did the universe start? Well, we say that the Big Bang Theory is how it started. So that's an important lens for us to look through this information through. So keep that in mind as we go through here. So first and foremost, what is the Big Bang Theory? Well, the Big Bang Theory is an explanation of the beginning of the universe. So how did the universe start? Well, as I said, science says that the Big Bang Theory is the explanation, the current accepted explanation for how the universe began. So remember, all of these words that are underlined here should make their way into your notes. So be writing those down as you're watching this video. This theory is based on evidence found in the surrounding universe. And believe it or not, we've actually talked about a lot of this so far when we've talked about CMB and did some debriefing on CMB. We've talked about Hubble's law and redshift, figuring out that, yeah, the universe is actually expanding the more and more time that passes. So the theory states there's really two main parts to this theory. Okay, the first part is that it started from a hot, dense state. So compacted into the smallest point possible called a singularity. So everything was packed together, all that matter, all that energy packed together into one single, infinitely small point. So trillions of times smaller than the tip of a pencil. We're talking super, super small, the smallest point that exists. And then the second part of the Big Bang Theory is that it happened 14 billion years ago. It started expanding and it has continued to expand for all 14 billion years. So not only did it start to expand right at the beginning, but it's been accelerating and continuing to expand ever since. So really two big pieces there. It started as a hot, dense state together, packed together in this small point. And then over the last 14 billion years, it's been expanding and continues to expand as well. So those are the two big key pieces of info you need to know about what the Big Bang Theory is. Okay, so let's dive a little deeper here. This expansion means the amount of space between objects in the universe is increasing over time. So your teacher may have shown you something like this, right? The balloon is actually expanding when we inflate it, but the objects, the stickers I have on here themselves are not expanding, right? So the stickers are staying the same size, but the balloon in between it is actually expanding. So the objects, the galaxies, the stickers in this balloon are getting farther and farther apart, but they're not expanding themselves. So the galaxy is staying its same size, it's just moving farther away from other galaxies. I know that that's something we've covered a ton so far, so that's a really important concept for you to know as we move through the rest of this unit here. So the raisin bread example over here, this is a classic example. This has been around forever, right? This is something I learned about when I was in middle school. So all of these raisins, when the bread gets baked, all of the raisins stay the same size, so they represent the galaxies. but the space in between the raisins, that bread in between the raisins, is the stuff that's actually expanding. So another look to see that actually all of the raisins are getting farther away from each other, but the raisins themselves are staying the same size. Okay, let's jump over to the right side of your notes. There's 2 questions I need you to circle here. So based on what we just talked about, raisins, like galaxies, are getting farther apart, closer together, and then the size of the actual raisins would be getting smaller, staying the same, getting larger. So you can do those 2 circles over on the right side. Okay, so the video we watched at the beginning of the unit, the Engage video, talked a lot about this portion of the Big Bang, right? Talked about the radiation epoch at the beginning. Well, all of this over here, the beginning of the Big Bang, is really just this like hot primordial soup of just stuff, extremely hot. I mean, look at the temperatures we're talking about here. 10 to the 27th degrees Celsius. That's like melt your face off heat, okay? 10 to the 27 is 10 with 26 or 27 zeros behind it. Insanely hot. And then we see as time progresses here, going from 10 to the 27th to 10 to the 13th to 10 to the 8th, gradually it's getting cooler. Now again, 10 to the 13th, 10 to the 8th, melt your face off. Incredibly hot still. Same with even 10,000 degrees Celsius. Melt your face off, okay? But over time, it's really important that we realize that, yeah, it's actually cooling down over time. And we also know over time that it's expanding. So not only is it cooling down, but it's expanding at the same time. You can think about it like there's a lot of heat in one area. Well, if we move away from that heat, it's going to cool off, right? If we spread that heat out, it's going to cool off over time. And then when we start to get into when stars and galaxies start to form, now we're talking, yeah, pretty cold out in space, right? It's pretty cold to be out in space unless you're near a heat source. So one last thing from this flow chart here. So we see that the beginning part is like super fast, right? So we have Big Bang, and then all of that stuff is happening in 1 second. And then we start to chill out a little bit. We start to form nuclei. So we start to form hydrogen and helium, just the nucleus. And then over time, everything starts to chill out even more. It's cooling down, chilling out. The electrons are finally relaxing a little bit. So then the hydrogen becomes an atom. It has an electron orbiting around it. The helium becomes an atom as well. And that's really important for us because that's how we get all of the elements we have today. So as the universe expands and cools, it allows these elements to come together and form atoms. And that is really important because, I mean, our bodies, we're carbon-based life forms, right? Well, if we don't have elements, we don't exist. So it's extremely important. And we're going to talk a little bit about what a proton is, this subatomic particle, this blue positively charged subatomic particle. So hydrogen exists with only 1 proton. Therefore, it's easy to say that, yeah, as soon as we have protons, all of a sudden we have hydrogen, right? Because all it takes is 1 proton to make a hydrogen. So as soon as we have protons, if we go back here for a second, as soon as we start to form these protons, all of a sudden we have hydrogen, just like that. Because a proton is a hydrogen. So that's really easy for the universe, right? It's provided it's cooled down and there's these protons that have been generated. Well, it's easy to say that, yeah, hydrogen's the first element that's formed because it was super easy for the universe to actually form that. All it takes is 1 proton. Now, as we'll talk about a lot in our next unit, when we have a proton and they're moving at super fast speeds and they smash together, well, in space and in astronomy and in science, when 2 things smash together and stick together, we call that process nucleosynthesis. That's what this big word is right here, nucleosynthesis. And another word for that, which you may have heard of before, is fusion. So we will talk a ton about this in our next unit. But for now, all you need to know is that when they combine, it's called fusion. And that helps us create heavier elements because instead of just 1 proton, we now have 2 protons. There's some neutrons in there as well. There's some electrons in there as well. So that creates a heavier element. And then the next heavier element after hydrogen is helium because it's 2 protons together. And then 1 step up from helium is lithium. So that would be 3 protons there. So they can kind of crush together and create this bigger, heavier element. And eventually, that's how we get all of the other heavier elements as well through a similar process. Okay, we're almost done here. So importantly, hydrogen and helium are the most abundant elements in our universe. What does that mean? So about 98% of our universe is made up of all hydrogen and helium. So just those two. Well, if we look at the periodic table, those are the top. They're the easiest to form. Not only are they the easiest to form, they're the smallest and they're the first to exist as well. So we consider those two, hydrogen and helium, the building blocks of the universe. We also get a little bit of lithium and a little bit of beryllium in there as well, but it's mostly hydrogen and helium that are those building blocks, and then everything kind of comes from that. And we'll talk about, really we only talked about 4 of these elements. Well, there's a ton of other elements here that we'll talk about in our next unit, how we form things like carbon and oxygen or gold and silver and mercury and stuff like that. Okay, so last thing you need to do at the bottom of your notes, there's a summary question. And it says, what can we observe in the universe as evidence for the Big Bang? And I want you to try to think about elements first. So think about what I said about hydrogen and helium being the most abundant elements in the universe. How does that prove, or how does that support the Big Bang? Remember that the Big Bang says it started as a hot, dense state. All of matter was compressed in there, and then it's been expanding ever since, expanding and cooling. So knowing that hydrogen and helium are the most abundant elements in the universe, and knowing about the Big Bang, what can we observe in the universe as evidence for the Big Bang? That's what you'll need to try to fill out at the bottom. Then after this, you can jump over to Learning Target 1 and answer Learning Target 1. Should come straight from these notes that we just done. Okay? If you have any questions, reach out to your teacher. We'd be happy to help. Otherwise, there you go. Part 1, Big Bang notes done.